Okay, today we're going to go over simple interest. So we're talking about our financial math. Now I'm just going to go on this other page here. There are a lot of formulas here. Okay, you're eventually going to get into some of these annuities and stuff like that. Yeah. But simple interest or calculating interest this is calculating interest. Do I have the simple interest formula? Oh, I don't even have the simple interest one. Sorry. This is calculating interest on a simple interest. And then along with that, there's another formula. Now, there's a lot of letters in these things, so we're going to try to make sense of all. A equals P plus I. Okay, so this is A stands for the total amount of total amount. Okay, total future amount, we'll say. And the reason we say future amount is because A can also be known as future value. Okay, and what that means is like 10 years down the road, 5 years, that's how much money you're going to have. P is called your principal, which is the amount of money you put in, but it can also be known as the present value, the money you have right now and you've put into the bank. Okay, and I is the interest earned. Okay, so in dollars, interest earned. So what this is saying, these two are the same formula. I'm going to say or, okay? Same formula. What this is saying is the total amount or the future value is equal to the amount of money you put in now plus the interest you earn on it. Which makes sense. You put in $500 in the bank, earn $100, you have $600 in the future. Right? It's a pretty simple idea. This formula goes along with it. I equals PRT. That's how to calculate your interest earned. Okay, P is still the same. It's principal, or the present value. Now, lowercase r, and you're going to have to get used to upper and lowercase letters here. You're going to have to try to remember the definitions. Lowercase r is your interest rate. Okay, so they're talking about the interest rate here. So whatever the interest rate is, that's what our lowercase r is. And T, do I have it in there? No. T is got several definitions. T is equal to time, or it can be known as the number of periods. Okay. But we're going to try to make sense of this. Now, the thing with simple interest is it's not really used today. You put money in a bank, it doesn't earn interest this way. You give money to a friend, you probably don't earn interest this way. We really don't use this in the business world, but it's the basis of the idea of interest, so they kind of make you go through it. So, simple interest, let's kind of talk about it. Let's say we have a question where you have $100, okay, so you have $100, and you earn 10% annually, 10% annually for 5 years, okay? So this is kind of our question. We got to figure out how much money we're going to earn. Well, in simple interest, let's define our variables, okay? Our, excuse me, our $100 is going to be which of these? Do you know?
P.
P, it's going to be the principal. Our 10% will be what letter?
I.
Well, remember, I is interest earned, and I'll put in dollars, okay? R is our interest rate, and that's what this is, 10% annually. And our 5 years is our time. So we'll kind of highlight these so that we can make sense of them. This is our principal. Okay, so it could be there, could be this one here, could be this one here. This is what that's talking about, principal. R is 10%, which is shown here, and it's the interest rate. Okay, and T is 5 years in this case, which is our time or number of periods, and it's also put in there. Okay, so if you notice right now, I don't actually have the information to solve these top two formulas because I don't have I haven't highlighted anything for I actually have to solve for I using the three values that I have. So the way simple interest works is you earn an interest amount, and every single period you earn that same interest amount. So let's make sense of that. What that means is I is equal to, the principal was $100. Sub that in for their P. Okay. The interest rate. Now, 10%. We actually have to turn that into a decimal. Do you know how to turn percentages into decimals?
0.1.
Yeah, and how did you do that?
1 equaling 100 or divided.
Yeah, we just divide, by 100. That's our data there. So 10% divided by 100 is 0.1, so we put in 0.1. That's the decimal form of 10%. And it's for 5 years. And what's important here is you do have to make sense of this. This is 10% annually, which means what?
Every time.
Every year. Annually means every year. So if it's for 5 years, that's 5 years is 5 periods, okay? Almost think of T as our period. So it's going to be 5 in terms of our time. This is a simple one, okay? So, zoom in a little. Let's make sense of all that. So we go to calculate this. Our interest earned is 100 times 0.1 will be 10. Times 5 is $50. Okay? So our interest earned is $50. So the idea along with that is think of it like this. Year 1, we earned $10, right? 10% of $100 is $10. Year 2, we earned 10. Year 3, 4, and 5, how much do we earn?
10.
We earn $10 every single year. So, $10 every year accumulates to $50. So we've earned $50 in interest. How much money's in the bank, which is our A or our future value formula, right? Say A is equal to the principal. Well, our principal was $100 plus our interest earned, which is $50. So we have $150 in the bank. Okay? So what happened there is we just earned $10 every period over 5 years, $150. Simple concept. Not really used today. What happens is normally, and we'll do a question or two of simple interest, and we'll move on to something called compound interest. Normally what happens is after the first year, how much money do you now have in the bank?
110.
110. Normally you earn interest on $110 now. And every amount you go up, you earn interest on the interest you've earned. Simple interest does not work that way. You get that amount, you get that same amount year after year after year. Okay? Does that idea make sense? Yeah. So here's another question like that. Just asking for something different. Before we solve for what the future value would be, right? In this one, you have $500 right now. You put it into an account for 6 years. After 6 years, you have $750. What was your annual interest rate? So, let's try to figure this out. There's a couple ways we can solve this. Remember, we have two formulas, our A equals P plus I. And we also have our I is equal to PRT. Now, they're asking us for an annual interest rate. Which variable are they looking for? R. They're looking for R in this question. So, annual interest rate, they're looking for R. Do I have an R in the other equation? No. So, we might want to use this one. Okay, just depending on what we do have. We have $500 now. What does that stand for?
Our principal.
Principal. Okay, so we have 500 now. So, well, there's a P in that equation and a P in this equation. That's good. And how long do we put it in for?
6 years.
6 years. Okay, great. We've used that one. Put in for 6 years. Okay, and we're looking for an annual rate, so that's perfect. That goes along with this. So we have 3 of the variables right now. Right. And what's the other piece of information we have?
Our interest. How much money we got out of it.
How much money did we get out of it?
$750.
Is that our interest or is that their total amount or future value?
Future value.
Yes, that's the future value. So that's our future value. Already use red. Let's use red. No, red. Okay. So the future value is $750. That's our little amount. Well, let's kind of look at this question. There's no R in this one, so I can't quite solve for R yet. But I also don't know what I is, right? I'm missing too much information. I'm looking for R in this question. I'm still missing a lot of information. Well, there's several ways we can go about solving this. One of them is that we know that I is equal to what? We don't know I is equal to 750. We know it's equal to these three variables. So that means I can replace this I in the other equation with those three variables. A equals P plus, and we'll replace it with this. P R T. Okay. Well, I have principal. Let's actually highlight things we do have. We have an amount. We have the principal, right? It's $500. And we have the time. Well, now we can isolate for our R. We have all this information. So let's plug our information in. Our total amount is $750 is equal to the principal is 500 plus 500 times R times how many years?
6.
6. Right? My goal now is to isolate R. So I move 500 to the other side. I get 750 subtract 500 is equal to 500 times R times 6. Right? What's 750 minus 500?
250.
250. Now, what does 250 represent?
How much?
What 250 could represent in this one?
Money you earned from your start.
What do you mean from your start?
From $500, you earn 250. From the initial interest.
Ah, yes, you're right. 250 is actually our I. Okay. So, and if you notice, it's set equal to that right now. Right? I is PRT. Well, that's exactly what we got. This is our I, this is our P, our R, and our T. So I could have quickly subtracted 750 from 500 and plugged it into I to solve for this, or I could do it the way we did it here. Either one will solve. Okay? I know there's a lot of colors going on right now. So, well, let's keep going here. We got 250. Well, I need to move 500. I'm going to move that one first. So we move 500 over, and in order to do that, we divide both sides by 500. This is actually going to become a half, or 0.5. So 0.5 is equal to R times 6, and we're trying to isolate for R. So I move 6 over. Divide by 6 on both sides. Okay. Our annual interest rate is 0.83. 0.083. What is that as a percentage?
8%.
8.3%. So we just had to do a little reversing of our equation. So in order to find the annual interest rate, you were earning 8.3% every year for 6 years in order to go from $500 to $750. Okay, now this isn't too common with simple interest, but here's a specific question. Let's say that you have $1 million after your great-great-grandfather left money in an account 300 years. Oh, for 300, not yours, years. Y-E-A-R-S, okay? You know the interest rate you received was 3% annually. A couple of spelling mistakes here. 3% annual interest rate, but you received interest semi-annually. Okay. Now that's not very common with simple interest, but it's going to expose us for something for compound interest, so we might as well get used to it. You don't know how much money your grandfather put into the account. To start, how much did he put in the account 300 years ago? So it's asking you to solve it. So we have our formula. So we know our amount is equal to the principal plus the amount of interest you earned. And the interest you earned was equal to the principal times the interest rate times the number of periods. Now this is important. Okay. Now, what I want you to get the idea of here is because it's simple interest, this little thing we said here, this one line, you know that the interest rate you received was 3%, was a 3% annual interest rate, but you received interest semi-annually, is actually not too relevant. It's much more relevant with compound interest. It's not going to make a difference how we set this up. I just want to show you that there are two ways to set it up. Okay. What are we looking for?
How much money did we start off?
And what variable is that considered? principal. We're looking for the principal. Okay? It's actually not an easy task to look for a principal in a simple interest rate. So let's put some information in here. What's the total amount at the end?
1 million.
Yeah. Got $1 million. That's his amount at the end. What was the interest rate?
3%.
Yeah. 3% annual interest. But you received interest semi-annually. This is going to make a bit of a difference. So that's our interest rate. And how much time was it in there for?
300 years.
Yeah, not 300 years. 300 years ago. Okay? So we got that. Again, we don't actually know what I is, and we're trying to solve for P. So we're kind of missing something here. So, again, what I'm going to do is because we know that I is equal to PRT, we're going to replace I with PRT again. A is equal to P plus PRT. Okay. Now the problem is I'm looking for principal, but I have two variables of principal. There's a P and then there's a P here. And when we were doing quadratics, that's the whole reason we would do factoring and stuff, is because we'd have two x's. We'd have an x squared and an x. We couldn't combine them. So we need to do some type of factoring. What we're going to do here is common factoring. And I don't know if you remember common factoring, but we look for a common variable between this term and this term. Is there a common variable here?
P.
Yeah. So what we're going to do is we're actually going to factor out the letter P. Okay. So just like common factoring, we divide each of these by P. What ends up happening is we get A is equal to, the P comes to the outside. What's left inside?
RT.
Well, what's P divided by P?
P's.
What's 5 divided by 5?
1.
1. P divided by P?
1 P.
Just 1, right? Just like 1 divided by 1 is 1, right? Same thing. And you're right. No, that looks like a T. But plus RT, right? Because these P's make a 1, so it's 1 times RT. It's just RT. So there we go. This is still the same formula as above. It's just written a little different, and there's 1 P. In fact, we could consistently use this formula if we liked in order to solve it. Now, let's plug in some of the information. The total amount is $1 million, which is nice. Principal is what we're looking for. 1 is the number 1. The interest rate. Interest rate and time is going to change depending. So I'm going to put a big OR. There's two ways we can write this. We could write it as an annual interest rate of 3%, which as a decimal is 0.03. And how long was it in there for? 300 years. Okay. 300 years. Okay. Or, and I guess we need a little more room for this. Kind of slide it over. Or there's the option of $1 million is equal to P. Again, we're still looking for it. 1 plus. Remember I said we receive it semi-annually? Do you know what semi-annually means? Half. Every half year. So we don't receive 3% at the end of every year. We're going to receive half of that semi-annually. So I'm going to take 0.03 and divide it by 2. But if it's for 300 years and I receive interest every half year, how many periods passed?
600.
Yeah, we multiplied 300 times 2. Okay. Now what you're going to discover is this times this, or this new number, which is 0.015 times 600. It's going to give us the same amount in the end. But it's just, I want you to get used to this idea of halving something or multiplying by 2 because we're going to need to do it for compound interest. So let's continue with what we got here. $1 million is equal to P, 0.03 times 300 is 9. Oh, that's nice. So that's 1 plus the number 9. And in the other one, okay, 0.03 divided by 2, 0.015, and then we know it's times 600 times 600. It's 9 again. We got the exact same thing, so I'm not going to write it again. But just get used to that is a possible idea. We then get $1 million is equal to the principal times 10. We divide $1 million by 10 when we bring it over. What is the original amount of money that he put into the bank or into the account? Do you know?
100,000.
100,000. What a nice grandfather you had 300 years ago. So your great-great-grandfather put in $100,000 300 years ago, and he eventually earned how much money in interest? 100,000 in interest. That's pretty good interest rate, right? So that would be a tougher type question for simple interest.